Hello, my name is Ying, and I'm a Year 4 computer science student in SCSE. My FAP project is Deepfake detection, and this project is supervised by Professor Chen Loi. Basically, this project is about training a model to detect whether a video or a picture is real or fake. And this fake means whether the video or the picture is generated by a computer or is captured by nature. First of all, I read some papers in the field under the guidance of my professor and my mentor. After understanding the field of deepfake in general, I focused to the exception, which is a baseline model in this field, and perform nearly the best of all the models. And the structure is basically like that. The exception model is divided into 3 flows, namely entry flow, middle flow, and exit flow. There are 36 layers of convolution divided into 14 stages. And there are 4 entry flows, 8 middle flows, and 2 exit flows. After all these preparations, the next thing I need to do is re-implement the exception model. And first of all, we need to do is to handle the dataset correctly. We need to split the dataset into real and fake. Also, we need to split it into train, test, and validation. There are 2 methods. And firstly, I just write a train test validation split function and use this one to input the test ratio and train ratio to split the dataset, and it's totally random. And the other one is this JSON to text split. This one, the JSON files are provided by the dataset, and this one is used in the paper. So I use this one to do the comparison with the statistics in the paper. And before we use the model.py to train the actual exception model, we need to write a custom dataset, which is used to load the data to the model. And since every dataset and model use like different types or different functions, so we need to write our custom dataset to be used. And our is mainly the image labels, length, image direction, and the transform. So after that is the most important part, which is the training part. And basically we use the exception class, which is constructed based on the architecture graph shown just now. After training and testing on the datasets, we got this table which shown the comparison of my exception results and the results in paper. So we can find that the paper statistics is better than mine, but overall it is similar and the results are satisfied. So the next step is to move on to a more advanced model, and the one that I re-implemented is called RECCE. So basically, the 2 methods are implemented in the similar way. We first use the architecture for the model, and then we do the testing. And for this one, I trained and tested on 2 different datasets, which called FF++, which is the face forensics, which is the most popular and famous dataset in deepfake detection. And the other one is the DFDC, which is the largest dataset in deepfake detection. These pictures are from the FF++ dataset. We can see we apply the mask on the real image to get the fake images, which is in 4 different manipulations, which are called deepfakes, face-to-face, face swap, and natural textures. We can see they are quite different from each other for these 4 different manipulations. So that's why generalization is a quite important thing in deepfake detection, and that's why we need to look for more advanced model which is more generalizable for different manipulations. As we expected, the test set AUC is extremely low when we trained on some kind of manipulation and tested on other manipulations. And we find the similar results in the paper as well. And we also compare the results for RECCE model in different datasets like FF++ and DFDC. And we found FF++ performed much more better than in DFDC. The reason for this is that DFDC is much more larger than FF++, and it contains much more kinds of manipulations in real scene, which is more difficult to be detected. In the last step, we do the comparison of exception and RECCE model. We found that the RECCE model performed much more better than exception model. This is quite consistent with our expectation. And the reason is that the RECCE model has more advanced structure, which provides is the quite good generalizability compared with the exception model. So in the future, with the rapid development of facial manipulation methods, we need to develop more generalizable model to do the detection much more efficient and accurate. Thank you for listening, and that's all from our video.